Today we are going to graph, write, and analyze linear regression equations. In this lesson, it should be a bit of a review from Algebra 1, but we're going to take a look at how we can look at graphs that are not exactly linear and write a line of best fit equation for them. So first of all, when we have data points, sometimes they're not exactly going to be a line, and therefore we want to determine what kind of correlation the two variables have in common. So positive correlation is our first type of linear regression, and two variables will have positive correlation when they generally follow a pattern, and they can be kind of all over the place, follow a pattern of increasing on the coordinate plane. It's not going to be exact, but they generally look like it's increasing. That would be positive correlation. Two variables would have negative correlation if they looked something like this. Again, nothing perfect. But if you notice, that looks like it's decreasing. That is our negative correlation. Two variables have no correlation if the points don't seem to have any relationship. So there is no relationship. Okay, so you have positive correlation, negative correlation, and no correlation. Because when we look at scatter plots, we're looking at two variables. We're comparing two different things and trying to see if there is a relationship. So our best fitting line, the best fitting line is a line that best fits the data points on a scatter plot. It's a word we should have seen before. A scatter plot is just this. It's all the points. They are scattered out. They are not exactly in a perfect line. So we're going to use the graph to find the equation of the line of best fit. Our line of best fit, we are going to use y equals mx plus b form. We are going to use our slope intercept form, just as we talked about last class. So as you can see here, the data collected, so we get scatter plots from real life data. So this data here is typing speed. I'm comparing weeks of practice, which is my x value. It's on my x-axis. That is my independent variable. I'm comparing weeks of practice to my words per minute. So my words per minute is on my y-axis, and that is my dependent variable. So my words per minute depends on how many weeks of practice I have. And you can see it follows a positive correlation. As weeks of practice continue, my typing speed gets faster. So my line of best fit here is going to be y equals 8x plus 16. That is the equation for this line you see going through here. That is my line of best fit for these data points. So I'm going to use this line of best fit here to predict the words per minute for 15 weeks of practice. So I'm using this information that I've collected to predict what might happen in the future. So I look here and see I have they're asking for 15 weeks, and weeks is my x. So I'm given x equals 15. So when I solve this, you can use your function notation to help you out here. F of 15 is going to be equal to, I'm going to substitute in for x. 8 parentheses 15 plus 16 is equal to, and you can type that right into your calculator. 8 parentheses 15 parentheses plus 16, and we get 136. So 136, I'm going to put WPM, words per minute. Okay, so if I practice typing for 15 weeks, I'm likely to be around 136 words per minute. It's a prediction. It doesn't necessarily mean it's going to be exactly that, but it's a prediction based on the data we've collected. So using your calculator, in the previous example, I gave you the regression equation, but you are going to have to find it yourself. So let's take a look at some sample data. So the table shows the minutes, okay, spent texting during class by FATA students on the review day, along with the grade they got on the quiz on Friday, okay? So here, my minutes texting, that is my X value. That's my independent variable. And my grade is my Y value because my grade is dependent on how many minutes texting I spent during class. So we're going to enter this data into our calculators. So you can take out your calculator, and you notice here it says we're going to hit stat and enter. So on my calculator, I'm going to hit stat and enter. And yours should be blank, okay? You're going to enter in all of the X data into L1 and enter all of the Y data into L2. Go ahead and pause this video while you enter that data in. Now that you have all of your data entered into your calculator, we are going to graph this into a scatter plot. We're going to see what this scatter plot actually looks like. So our directions here say we're going to hit second Y equals enter. So this will turn your plot on. So on my calculator, I'm going to hit second Y equals and enter. You notice it's already set to off. We're going to hit enter to turn it on. And you can see this tiny picture of what looks like a scatter plot. Okay. So now we are going to find the equation. So once we have that turned on, now we can find the equation. So we're going to hit stat, go over to 4, go over to calc, go down to 4, okay? And then we're going to hit enter a bunch of times, okay? So if we look at our notes, these directions are on your notes. So we hit stat, I'll do that again. We hit stat, go over, that's your arrow, go over to calc, and we want to do number 4 because that's our linear regression. You see it says AX plus B. I'm going to hit 4. And then I hit enter until I get down to calculate. If you see it says my X is L1 and my Y's are L2, that's what we typed in. So I'm going to hit enter, and there is my regression variables. Okay, so let's record those. So my A, I'm going to round to 2 decimal places, is going to be negative 2.48. That's my A. My B is 102.73. Remember what these means. Remember what these mean. My A is my slope. I know we usually see it as M, but in the calculator they put A. So my A is my slope and my B is my Y-intercept. So when I write the equation, Y equals AX plus B, Y equals my A value, negative 2.48X plus 102.73. Okay, this is my line of best fit equation. For the line of best fit. That is what I have here. That's my equation. Okay, now we can actually see that and get a picture like we had on the front of our notes. So now we're going to put the scatter plot and the equation of the line of best fit on the same graph. So the first thing we want to do is go to my calculator and go to your Y equals screen. If there's anything in there, make sure you clear it out. There should be nothing in your Y equals screen. Okay. Then we're going to go back to stat, over to calc, down to 4. Okay. And this time we're going to scroll down. We have to go down a little bit to where it says store regression equation. Now we're going to hit on your notes, it says vars. The vars button is right here. We're going to hit vars, over to yvars, enter, enter, enter to calculate. And our screen should look the same. But this time what I'm going to do is go ahead and hit zoom and then 9, and there is all of my data points along with my regression equation. So that's how you can see it all in your calculator. Okay. So when we want to predict values using the line of best fit, we're going to use our line of best fit from example 2. This is like we did at the beginning of our notes. So once you write the equation, you can use your equation that we got in example 2. So remember that equation was, you can write it up here or you might be able to see it on your paper, y equals negative 2.48x plus 102.73. Okay, so that's my equation. I'm going to use that equation to predict the grade. I want to predict the grade I get. Remember that my grade was my y value. You would receive if you texted for 35 minutes. Remember, minutes is my x value. X is equal to 35. So when I solve this, I'm looking for y and I have x. So I can use my function notation again, f of x. Oops. F of 35 is equal to negative 2.48 parentheses 35 plus 102.73. You can go back to your calculator and type that in. To get out of here, you can just hit clear, and then you're back to your screen. Negative 2.48 parentheses 35, close the parentheses, plus 102.73, and we get 15.93. So what this means is I would get approximately a 16% on the test, okay? So if I texted for 35 minutes, I might get a 16% on my grade. Letter B says use your equation. So we're going to use the same equation to predict. Again, we're predicting how many minutes. So minutes is my x. A student most likely was texting if they received a 55%. So y is equal to 55 on the quiz. So this time, instead of putting it in here, we're going to set our equation equal to 55. So 55 is equal because this is y equals and this is y equals. So we're set them equal to each other. Negative 2.48x plus 102.73. And we are going to solve for x. Okay, so I'm going to subtract 102.73 from both sides. They cancel over here. When you subtract that, I get 55 minus 102.73. I get negative 47.73. Is equal to negative 2.48x. My last step to get x by itself is to divide both sides by negative 2.48. They cancel over here. Type into my calculator. Negative 47.73 divided by negative 2.48. And I get 19.2. I'm going to round that to 2.6. So x is equal to 19.26. I'm going to round that to approximately 19 minutes. So if I got a 55% on my test, I was likely texting for 19 minutes. Okay, so what should you do next? You're going to work on the linear regression practice. Please make sure you are doing your best work. When I get back to class, I will be checking and answering any questions that you have. You will have an exit ticket at the end of today's class, so please make sure you are using your time wisely.